let's actually go through now and solve a system by elimination. So let's start with this single equation, 3x minus 7y is equal to 27. Now I can't solve this equation as it is because I have two variables and I only have one equation, it does let me solve for y in terms of x or x in terms of y, but there's no way to get any sort of number to pop out. I need at least two equations in order to solve this system right here. So negative 3x plus y equals negative 9. This will be our second equation. So with these two equations, I now have enough information to solve for their intersection point. This is a line, and also this top one is a line. I can find their intersection point. I can find where they cross each other. So here's what I'm going to do, and we probably don't actually need to do it for this particular example, but in order to stay consistent, I'm going to try and keep the same notation throughout. I'm going to call this equation number 1, and I'm going to call this one equation number 2. So for equation number 1, what I'm going to do to it is absolutely nothing. I'm going to keep it the same. So I'm going to write 3x minus 7y is equal to 27. The reason that I'm writing this is because it's about to get more complicated, and I just want to keep track of which equation I'm doing something to you. I want to keep track of what I'm doing, so that way if I have to go back and I have to check where did I go wrong, or if I want whoever's checking my work to know what I was actually doing, it makes it a little bit easier on the both of us. So for this green one, I'm also not going to do anything to this one. I'm going to keep it as negative 3x plus y is equal to negative 9. Now if you recall, I can add the left sides together and get a result, and I can add the right sides together to get a result. This is really going to work best if I have the x's and y's on one side and have all of the constants on the other side. And I'm lining these guys up. What I notice is that if I have 3x and I have a negative 3x, those guys are going to drop out and I get 0 x's. I don't really need to write it, but just for emphasis, I'm writing 0x. And I've got negative 7y, and I'm adding y, so I have negative 6y. And now if I take 27 minus 9, that gives me 18. And I'm going to rewrite this without the 0x. And then if I divide both sides by negative 6, divide by negative 6, I would get y is equal to negative 3. From here, if what I should do is, after circling this, this is one of the coordinates that I'm solving for. So I definitely want to draw my reader's attention to this part of a solution right here. And then I can plug this back into either one of these equations. Let me just do equation number 1 just for kicks. I could also plug this into equation number 2, and it should come out to be the same thing. Negative 3x minus 7, and I've got a y here. So instead of a y, I'm going to substitute this back in. And then I get equals 27. And if I solve this for x, I would get x is equal to 2. And now my final answer is going to be my x coordinate, comma, y coordinate. This is the point of intersection for these two lines. So they're going to cross each other when x is 2 and y is negative 3. Now let's take a look at what we actually did here. I had 3x minus 7y, so I have an x variable and I have a y variable, and this is just a constant term, so I don't really need to worry about adding any more variables here. I have an x and a y, and what happened was when I added these guys, the x's dropped out, and all I have now is a y. I don't have to worry about x's. Now I have one equation and one unknown. I can solve this for y and then plug it back into either one of the equations and solve for x. So the whole point of this, the whole point of elimination, and this is where the word elimination comes from, I'm eliminating one of the variables by just adding these two equations together. One of them is going to drop out, the other one doesn't, and then I can solve for the remaining variable. Let's do this with a second example, and let's make it a little bit harder. They're not always going to match up really nicely like this. We're not always going to have a 3x and a negative 3x. So we need a way to figure out how to always make it drop out, how to always force one of the variables to fall out. And here's, let's try this equation right here. Let's do 2x plus 5y is equal to 15. Let's do 7x plus 7x minus 9y is equal to negative 133. Okay, so here's the problem. Now I have a 2x and a 7x and a positive 5 and a negative 9. These guys are not going to drop out if I try and add them together. So what I'm going to do is I'm going to again label these like I did before. This is equation 1, and this other guy will be equation number 2. And now what I'm going to do is I'm going to multiply this one by 7. I'm going to take 7 times equation number 1. And that's going to give me 14x, and that's going to give me a plus 35y, and and then that is going to equal a 105. And now for the second equation, I'm going to multiply this one by negative 2. So I'm taking second equation, multiplying that by negative 2. I get a negative 14x. Oh, these guys are going to drop out when I add them. And then I'm going to get a positive 18y, and that's going to give me a positive 266. Now when I add these guys are going to add up to 0, so I have 0 x's, and then I have 53y, and that's going to equal 371. Now, these guys don't matter. I have 53y is equal to 371. I divide by 53, I divide by 53, and I get that y is equal to 7. I can substitute that back into either equation. Again, I'm going to just stick with my first equation. I could use that second equation, that would be fine. And I would get 2 times x plus 5, and that's going to be 5 times 7 instead of y, and that's going to give me 15. And again, I'm using equation number 1, so I'm just practicing good record keeping here. And if I solve this for x, x will give me negative 10. I circle these guys to draw my reader's attention to that part of the answer, and so my final answer is going to be negative 10, comma 7. So let's take a look at what we did up here. The reason that we multiplied by 7 is to get this to become a 14. The reason we multiplied this by negative 2 is to get this to become a negative 14. Now, I always want these to be opposite signs if I want them to drop out. If they're not, I force them to be opposite signs. If I would have multiplied this by 7, I would have just gotten 14, and if I would have multiplied this by a positive 2, this would have been a positive 14. I need this negative sign in order to flip the sign to be a negative so that they'll drop out when they're added together. Now, if I would have, there's something else that I could have done also, and I will run through that one next. But I'm choosing 14 because it's the least common multiple between 2 and 7. Any common multiple between 2 and 7 will work to drop out the x's. So I just chose the least common one. I could have also made the y's drop out instead, so let's redo this problem, and hopefully I should get the exact same thing back out. So again, I'm going to, let me just copy these. I'm still going to keep that one equation 1, that one equation 2. And let's paste this guy in here. Okay, so again we have 2x plus 5y equals 15 as our first equation, and then we have 7x minus 9y is equal to negative 133 as our second equation. What I'm going to do this time is I'm going to make these y terms drop out. The least common multiple between 5 and 9 is 45, so and this one is already negative. I'm just going to keep this, this y term negative, and then I'm going to make this y term positive. So I'm not changing the signs here. In order to turn this one into 45, I need to multiply my entire first equation. I need to multiply that by a positive 9. So I would get 18x plus 45y equals equal 135, and then for my second equation I want to make sure that this guy ends up being a negative 45, so in order to do that I have to multiply the entire equation. I have to multiply the entire thing by 5, and that's going to give me a 35x, that's going to give me a negative 45y. Notice that these guys are going to drop out when I add them together, equals 665. And now all I have to do is add these together. So if I add these guys together, I get 53x, I get plus 0y, or minus 0y, whichever, and then now I get a nice round 800. So now I have 53x is equal to 800, and then I get that if I divide by 53, divide by 53, I get that x is equal to negative 10. That's not right. This should be a negative 665, and so that would change this, and it would also change this, and I would get a negative 530, and this would give me a negative 530, and that would give me a negative 10. And now, if I plug this back in, 2x plus 5y is equal to 15. If I take this x, plug it in here, I get 2 times negative 10 plus 5y equals 15. If I solve that, I get y, and I do end up getting that y is equal to 7, like it's supposed to. So here again, I circle both parts of my answer, and I get the point negative 10, comma 7. box around that. So it doesn't matter if I make X drop out or make Y drop out.